Hi, this is a presentation of access control list and the basics concepts of access control list, and it is a part of my advanced networking course. When we are looking at ACLs, it's something that we use to be able to filter the traffic. So we can go in and set what we will allow in or out of an interface. And we can do that in different ways. We can set filter according to the IP addresses, both the destination and the source IP. We can also do it on the port numbers so that we can filter different types of traffic. So we can go in and set that we will allow, for instance, email, but deny telnet here on one of the interfaces up here. So it's a way of deciding what we will allow or permit and what we will deny out or in of an interface. So what we do is that we can either set the ACLs to work on inbound or outbound, which means that we go and set them on an interface and set them for have a filtering inbound traffic or outbound traffic on the different interfaces. We set statements, and it's important to remember that when we start using ACLs, there is a implicit deny any in the end. And if we do not have any permit statements, then all traffic will be blocked. In the beginning, when you start making ACLs, you will probably experience that it's very easy to accidentally block all traffic, which is probably not what you want, but it's sometimes that happens. And it is because you cannot see the statement, but it's always there saying that the last statement will be, we will deny all traffic. When we look at the implementations in Cisco, we will see that there are two types of ACLs. We have the standard ACLs and we have the extended ACLs. The standards are very simple. We will only filter on the source address. They are not very useful, but in some types we can still use them. The extended list are more complex, where we can filter, like this example here, we can filter whether we want to accept both TCP and UDP packet. In this case here it's TCP from 192.168.30 to any network equal 80, which means that only it will filter on port 80. So here we can filter both on the type of protocol that we are using, we can filter on the port numbers, we can filter on the destination and source IP. So there are much more possibilities using an extended list. In Cisco, if we have a standard list, it will have a number from 1 to 99. And an extended list will have a number from 100 to 199. This is the way we differ between extended and standard lists. So they always have a number. Of course, sometimes it's easier to work with names instead, so we can name them. So we can go in and set names for both standard and extended ACL list. When we indicate the IP addresses using an ACL list, we will need to indicate how much of the IP address will we check. And instead of using the subnet mask, we here, as we do in some other protocols also, we use the wildcard mask. The wildcard mask means that if the wildcard mask bit is 0, we will have to match the corresponding bit in the address. If it's 1, then we will ignore it. So basically, the wildcard mask will be the opposite or the inverse of the subnet mask. And the way that we can calculate what it will be is that we take 255, 255, 255, 255 and subtract the subnet mask from that. Then we will find the corresponding wildcard mask. If we, for instance, want to check the entire IP address, we want to check the host IP address, Then we can do it in two different ways. We can do check 192.168.10.10 and then a wildcard of 40, which means that we will check the entire IP address, or we can use the keyword host. That also means that we will check the entire IP address. Another way, for instance, if we do not want to check anything, we don't want a match in any of the bits, then we can use 4 times 0 as the IP address, and we can use 4 times 255 as the wildcard. This means that all IP addresses will apply to this mask and IP. And we can also use the keyword any instead of using 4 times 0 and 4 times 255. So we can use the keywords also. So here, example 1, where we have an access list 1, which is the standard one, permit 000 and 255, 255, 255, 255, which means we can also, instead of writing this sentence here, we can use access list 1 permit any, because this here means any. Example 2, where we have access list 1 permit 192.168.10.10 and 4 times 0. It's the same as access list 1 permit host 192.168.10.10, because 4 times 0 in the wildcard mask means that we will have to check all the parts of the IP address. Yeah. So what are we using them for? Well, we are using ACLs to filter traffic typically between a border of a network. What we want to allow into our local area network, for instance, what we want to allow to certain parts of our network, we can set them between different VLANs. If we have large network where we have multi-area OSPF, we will typically set them on border routers and the edge of our networks, so that they will be. It's a very simple part of, or a simple way of setting up a firewall, because you actually go in and say what you will like to allow or not allow in and out of your network. So it's a packet filtering operation. There are some rules that applies to ACLs. There are the 3 Ps, which means that only one ACL per protocol, 1 ACL per direction, and 1 ACL per interface. So actually what we can have is that if we have a fast Ethernet 00 interface, we can only have 1 ACL per direction per protocol. So we can have 1 ACL working for inbound traffic and another one for outbound, for instance, but only one in one direction. When we look at the standard ACLs, since we can only filter on the source IP address, well, then we have to set the filter closest to the destination. So in this case here, if I want to deny traffic from 192.168.10.0 to this network over here, well, then I have to filter it down as close to the destination as possible, because if I do it here, I will stop all traffic from 192.168.10.0, for instance, and I do not want that. They may be allowed to send traffic up here, and also up here, and also down here. So it's set as close to the destination as possible, which means that we have to route a lot of traffic and then discard it in the end, which is a little bit stupid. So it is, in this case, better to use the extended ACLs, because the extended ACLs you can set as close to the source as possible. Because if I know that when I send something from this network over here all the way through this network over here and it will not be allowed in, I might as well filter it off in the beginning so that I do not have to send it. So extended ACLs are placed as close to the source as possible. And when we set them, well, as I said, we make these statements, and it will always start with the first statement and then go to the next and then go to the next. So it is important when we set the statement that we make them as general as possible in the end. We start with the specific things and then we make them more general. And we also need to remember that there is this deny any in the end. Even though if I set the ACL like here, where I do not have a deny any in the end, it will still be there. So sometimes it's easier for me just to put them in so I know that it is there. But it will be there anyway. Yeah, and that was it. That was the general things about ACLs.